3.4, we talk about something called absolute max min on a closed interval. A closed interval can be 1, 10. That's an example of a closed interval. So first of all, let's discuss about the absolute max. We have never talked about absolute max. We talked about relative max and min, but not about an absolute max min. Okay, so here's an example. So let's say I have this function. Notice that it starts here and it ends here. There is no arrow there. So the function goes up to a maximum. This is a relative max, but it's also an absolute max because there is, for this function, this is the absolute maximum possible. It's also relative. Over here, again, this is a relative min, but it's also an absolute min because this function does not have a value lower than it. This is it. Absolute max and min can also be at the end of the interval. Relative max min never can never be at the end of the interval. So here's another example. This point is the absolute max, but not relative max. Not relative max. Why? Because the relative max requires a function to exist on both sides. This is a relative max because the function exists on both sides and the function values are smaller. But here, at this point, the function does not exist on this side, so it cannot be a relative max. Here, it's an absolute min, but also relative min, because the function exists on both sides. This one is nothing. It can never be a relative because it's at the end point of the interval. And for this function, it cannot be absolute min because there is another value smaller than it. It cannot be the absolute max because there is plenty of other values. We find plenty of other values higher than it. So I like to open the book to discuss a few graphs. And this is on page 314. And let's choose a graph. 3, 4, 5, 6, any graph you'd like. As you see, they are given on closed intervals, 0, 2, 0, 2, -2, 1, and -1, 2. And just discuss the absolute max, absolute min, and also relative max, relative min. So let's choose one graph.
Can we do number 5?
Perfect, excellent. Okay, so in number 5, you see the first point that we want to discuss happens at -2 or exists at -2. Of course, the other one at -1, the other one at 1, or maybe 1.5, I'm sorry, 0.75, and the other one at 1. So let me write it down. So this is, we chose problem 5 on 314. So at x equals -2, what will you say? What happens here at x equals -2? I don't care for the y value. So when x equals -2, what do we say? The function has a
Increase?
Say it again. I couldn't hear you, Ariana.
Increase?
What type of point is that? I'm sorry, I wasn't clear. So we need to identify the point.
Relative minimum.
It cannot be relative because it's at the end point of the interval.
Absolute minimum.
Absolute minimum only. Absolute minimum. Now at -1, what can we say? What happens at -1? What type of point is that?
Is that an inflection point?
No, because there is no concavity change. Concavity is changing here. Down, up.
Would that be the relative maximum?
A relative max, and also
An absolute max?
and absolute max. It's relative because the function exists on both sides, and it also happens to be the absolute one because there is no other value higher than it. Perfect. Now here at 0.75, we're not looking for the point of inflection. That's we're not interested right now in the point of inflection. We are interested in absolute max, min, relative max, relative min. So what happens here?
Relative min.
Yes. Is it an absolute?
No.
No. Finally, what happens at 1? X equals 1. You cannot say relative because it's at the end point of the interval. Can you say absolute max or absolute min? Can you? No, because we already found the absolute max and absolute min. So this is nothing. Nothing. Doesn't mean anything to us. Perfect. Okay, so now let's study a function on a closed interval to find its relative, mainly absolute max, absolute min. Since we looked at rational functions so far, let's try something different. These are not friendly functions. The exponentials are not very friendly. The logs may not be very friendly. We have to try one. So you want to work on an exponential, or you want to work on the log? We have to work on one. Which one? Okay, I will choose 23 then. And we have f of x equals e to 3x minus e to 2x. And the interval is -2, 1. Okay. We'll read the question again in a moment, but immediately start the table, but you can only put this in, nothing else. -2 to 1, so f prime of x, and then f of x. So again, let's read the question. So find the absolute max and min values of each function over the indicated interval and indicate the x values at which ... Fine. Okay, so the first thing we need to do is find the first derivative. We're not graphing this function, so I don't need to study the function. I'm only asked to find max min. So I start directly with the first derivative in this particular case. Can anyone help with differentiating e to 3x, please? E to 3x. E to a function prime is e to the function times the inner function prime. What is the inner function prime?
3.
Perfect. Minus the same thing, e to 2x times the inner function prime, which is 2. Now, all we can do here is factor out e to 2x. We can. Let me rewrite it first. So 3e to 3x minus 2e to 2x. And we can factor out e to 2x. And we still have 3e to x minus 2. Now I have to find critical numbers. As I said, these functions are not friendly, really. So the critical numbers, this can never be 0. So f prime of x equals 0 means 3e to x equals 2, or e to x equals 2/3. If you remember, we've done this before. We have to apply natural log to both sides. So x equals natural log of 2/3. I don't know what this is. Obviously, I have to plug it in. So if it's not between -2 and 1, then it doesn't belong in the table. Most probably it's there. I didn't mean that. I meant this. Okay, so I want to see what natural log of 2/3 is. So it's a number -0.4. As expected, so x -0.4. As I said, this is not these functions. Okay. So I found the only critical number of this function, which is -0.4. I know the derivative is 0. This will never be undefined. This is the only critical number. And now I have to study the sign. I put this function in the graphing calculator. This is not easy to handle. So I will put the function in the graphing calculator, okay, as a secondary. So, oh no, this was a different function. So e to 2x to 2x, and then in parentheses 3, e to x, and then minus 2. So I want to plug in the function a number to the left of -0.4, like -2. That's good. And the other on the other side, 1. So at -2, so both are negative numbers. Okay. Okay. We're going to check in a minute. When we plug in the function, these numbers, if these numbers are not always increasing, then I know there is something wrong. You remember, these two rows have to work in sync. If they don't, I know, oops, something is wrong. Okay, so now we plug in the function in the graphing calculator. Okay, in y equals, so the second function will be the original function. And the first one was the derivative, e to 3x, and then minus e to 2x. Okay, so I need to plug in -2. I need to plug in -0.4. And I need to plug in 1. So when I plug in -2, yes, so I got -0.01. When I plugged in -0.4, I got -0.148. Okay. And then when I plugged in 1, I got 12.69. Okay. So obviously, let me check my e to 2x, copy the base, add the exponents. That was correct. Everything was correct here. E to 3x minus e to 2x. That was correct. I'm checking my calculations here. So we had, obviously the sign is wrong. So from here, the function is increasing. From here, the function is decreasing. That is correct. But I don't like this. So from negative 0.1 to negative 1.48, that's correct. But there's something is wrong here because it makes no sense. From negative 0.148 to positive 12.68, the function is increasing. So I'm checking my sign. So the first derivative, again, so e to 2x, that's correct. So we had 2 over 3, negative 0.4. Okay, let me see what signs I plugged in, what numbers I plugged in the first derivative. Okay. So in the first derivative, I plugged in negative 2, and that was negative. Then I cannot plug in negative 0.4. That was silly. I need to plug in 0. And I still get negative. But that's not possible. And I think there is some sort of error with the calculator. And now I remember that I encountered this situation before. So let me just do this with this calculator. So can you please, in your calculators, let's all check this, because I think there is an error with the software. So when you put in your calculators, when you put in the derivative, and I think that that's the case. So e to 2x, please grab your calculators. I need at least one person to help with this, please. So e to 2x times 3 e to x minus 2. So just put in the derivative. And in the derivative, plug in negative 2, plug in 0, and plug in 1. So I don't know if you can see this or not. So second and table, and plug in negative 2. That's correct. We get a negative number. Plug in 0. See? The software is a problem, has a problem. So at 0 and at 2, it's positive. But that's not what the software gives, which is a big issue here. Can anyone confirm that you got positive when you plugged in either 0 or 0.1 or 0.2 or 1 to this side with your calculators? Can anyone confirm that for this function? Anyone? Can anyone confirm?
Yeah, positive.
Yep. Yeah. So there is a problem with the software. I remember this because I had this situation happening before. Now it makes sense. And forgive me for holding you for another minute. So obviously this point, so I'm not graphing the function. So here is negative 0.01. Here is negative 0.148. And up here, I'm not graphing the function. I'm just putting those y values. So this point is nothing. This point is an absolute and relative min. Absolute, also relative, min. And this one, because he's at the end of the interval, is only absolute max. Thank you for your help with that.